Welcome to another simulation and prototyping tutorial. Today I want to share what I've been playing with in Grasshopper with the particle systems. And these can produce some really kind of amazing and beautiful form. And I'm going to show you just a couple of really simple techniques or simple aspects to get started with this, and then you can kind of play with it from there. That'll be a quick portion, and then what I'll do is I'll show a little bit more on what I've done in order to deal with some representational issues with this in terms of animating it and adding a little bit more control over what we see on the screen. So what we see is a really simple array of just a two-dimensional grid with three rotational forces. And the rotational forces are just controlled by three lines in Rhino. And I can change those lines. The other thing that we see are the ends of the field that I've just thickened with a small pipe. And I've also color coded the interpolate curves that come from the field with a gradient pattern based on the length of the curve. So we can see the darker lines with almost a kind of black burgundy color. They're the longest. And then the shorter lines are the more pink lines. The other part of this too is I will refresh the animation, and I'm doing this with the Anemone loop. And so I'll show you how to create this loop to animate this. And so what we can see is the grid, the two-dimensional grid starting, and then each of those points being swept up into the rotational forces that are applied to the field. And so we can see each point then kind of going through these for a certain period of time or a certain length. And I'll show you how to control those things. So once this finishes, looks like it's done, here I can even zoom out a little bit. We can see the loop as it runs. And so with this panel, we can watch it go through all of the steps. I'll just change the view maybe once more, and we can get a better sense for this. I'll reset it. And so we can see again that two-dimensional grid, each point then moving through the field. And so from a Grasshopper perspective, this is a pretty simple set of components. And once this finishes, I'll get started and show you just how I made this, and then imagine you can begin playing with it. Okay, so the loop is finished, and we see that. So it does produce, just even from a two-dimensional field, it's producing a three-dimensional, or from a two-dimensional array of points, it's producing a three-dimensional result. And that's pretty great. We can also do this with a three-dimensional set of points, but it wasn't even necessary here. So I'll show you how to do it both two-dimensionally and three-dimensionally. So why don't we get started? I'm just going to set each of these to be half and half again. And okay. And over in the background, we can see what I've done is I've baked it, and then also made a two-dimensional make 2D of this, of just a set of lines. But for now, let's start with a new Rhino file. And I guess I'll work in feet. I can't remember what the previous one was. And I'll start a new, I'll save this, and I'll start a new Grasshopper file. Okay, so drop in binoculars. So the first thing that we want to do is to start with a point. And we can do this. We know we can do this a number of ways. You can start by drawing a point in Rhino, you could start with, if we could actually just start with this, but we won't, it'll default to 0, 0, 0. I don't always like to do that. And so I'm going to start with a new point. And so I'm going to construct a point. And we can see that defaults to 0, 0, 0. Sometimes when I work, I don't like it defaulting to 0, 0 in case I want to try something and something else defaults there. So to avoid some confusion later. And so I'll just start with // and I'll make a small panel. And I'm going to set this to 200. I can make it a little smaller, and I'm just going to set that to the X. And so as I zoom out, now I've got a point from the 0, 200 over. That's enough for me to just move it away from the origin. So once I have this point, what I want to do, and I'll explain a little bit why I want to work this way. I want to create a range. And the reason why I want to do a range versus a series is that I actually want to be able to both constrain its dimension, but as we get further along with the construction in Grasshopper, I want to be able to add density to the field. And so this is a nice way to be able to do that. So doing the same thing, I'm going to create, actually I can just copy my small panel. And another shortcut here is I can say 0 to, let's say 50. As a way to define a domain. It's a really simple way through the panel to define a domain. And then steps is going to be the place where we'll increase the density within that range. And so let's start with a relatively small number. I'm going to copy that panel as well. And now let's set this to say, maybe let's start with 5. We'll plug that in for the steps. And what we're going to do is we're going to move that one point first in the X direction, then in the Y direction. So we're going to take that one point, we'll move it in the X. We can zoom in a little bit. We see those 5 points. And here's the difference. We'll come back and we can change this 5 later. If we change it to 25, what it'll do is it's going to keep it within this same kind of boundary, but it will increase the density. So if I just change it to 25, we can see we just get more points within there. I like that because as we start to add the other forces to the field, we don't want it to, if we were to use series, the series would get bigger and we would have to end up relocating our forces. And so we'll move this back to 5 to start. And so we see that density. Let's copy our move. And we'll feed in that move. We'll add the Y here. And we'll plug the range into the Y, and then we'll plug the Y vector into the motion. And we can see what it's doing is that it's giving us kind of alternating between those, but we should graft this. And now we see we get the entire field. So again, if we increase this to 12, we see that that density increases. If we wanted to do this with a Z as well, which I don't necessarily want to do, but we can show quickly, we'll just feed in all of these points and we'll add a Z. So we can do that and then that. And now we see we get an entire grid of points. But like I said earlier, just a simple grid in plan is sufficient for what we're going to work with here. So we can hide a few of these things while we're here, and I'm just using Control Q to do that as shorthand and hide those, and then we're left with our simple grid here. So that's really the setup for this. What we'll do next is we will add some forces to this. And so we could even group all of these together. And now we have that set. So the next thing that we'll do is we're going to add forces to this array of points. And what I'd like to do is maybe in the front view or side view is to just draw a couple of lines. And we'll adjust these in a second, but I want to draw them through the field, slightly different lengths. And what we're going to do is we're going to find the midpoint, and we're going to set the rotational field at its midpoint based on a plane. We can also relocate these. And then I even want to add maybe a little bit of rotation to them here. And so as we look in 3D or in the perspective view, we can even zoom selected. We can rotate around and see them. So once we have 3 simple lines there, let's build the forces within this. So we'll start by adding a curve container. And I'll build this once, and then we'll copy it and we'll use it 2 other times. And we can even just start maybe with 1 force to see how it works, and then we can add incrementally from there. So the way that we'll find the midpoint, well, let's set one of our curves. And we'll do point on curve. Which is a little, sometimes a funny component, because there's just 1 in and 1 out, but we can see it gives us, we'll set it at 0.5, and we'll set that a force right at its midpoint. And what we need for this is a plane. And actually, let's go up to vectors and planes. I want to get the plane normal. And the origin is going to be the point, and the z-axis will be the curve. And so now we can see we have a plane at the midpoint of our line. As we move our line, we can see that midpoint also moves. And so this will be the way that we can control the location of our field with the 2 endpoints of the line. It's a pretty simple way, pretty simple and interactive way to control this. We could also probably move our force anywhere along that line as well. And so that's another level of control. That's really nice. So that's all we need now. And I don't know if anyone's looked at these, but under vector, the first grouping of components up here is field. And so we have a number of different things that we can work with. I can probably do some subsequent tutorials with some of these other things. We have a point charge, which can either be a kind of attraction or kind of pushing away. I'm going to use the spin force today. We can also use the vector force. We're going to merge our fields, and we're going to use the field line. There are some other nice representational tools here to look at kind of sections through a field and look at visualizing some of those things. So let's pull the spin force down from here. We can see there's a number of plugins. First being plane. We have our plane. If we hide our plane and even our point and even our curve there, we can see a rotational force. There's some arrows, and from this view, it's moving clockwise. So we can set a couple of our other components here, and these feel very kind of subjective, but we can do these. We'll make a number slider. For strength. Strength is okay. Let's do -10 is less than 10. And we can see when it's minus, now it's counterclockwise. So as we move this and it turns positive, we can see that the directionality changing from negative or positive. That'll be a nice way that we can, as we have 3 of these, we can get forces to work in opposite directions. The next one, we can copy our slider. Actually, I'm not going to copy my slider. I want to set it up to be a little bit different. I had some problems with it where this crashed earlier when it got to 0. So I'm going to set the radius to be 1 is less than 10. And that way, if I ever change this, so we can see the icon of the spin force is changing as we change the radius. And then the last thing, let's do decay. And let's set this to be, let's see if it can be minus. -10 is less than 10. I don't know if I've tried a negative number here, but we'll see what it does. So we can put these together. So now we have this spin force. With that spin force, knowing that we're going to have multiples of these, I'm going to merge that. And so up under the field, we have merge fields. And this just allows us to bring these together. We do want to flatten this as it comes out. And the last part of looking at the fields is to use the field line. And what this does is essentially like an interpolate curve that looks at how many kind of steps. So in some ways, it's like a loop in itself. And we'll look at this, and I say that because it has steps. And so the field is going to be the force from these is going to be the field. The point is going to be our geometry from above, the points that we have here. And now we can see something is already happening. And the number of steps, I think, defaults to 1,000. And so we can even turn this down a little bit. Let's go 10 less than 1,000. And we can see what happens with the number of steps here. So as the number gets smaller, we can see that our individual lines being generated are smaller. As we increase this, we can see all of these points beginning to swirl around. So this is kind of the length that is generated by those curves. So now that we have this, we could even hide our points. And now you've made a field. Like I said, it's really simple. We could look at some of what's happening here. Maybe I will turn the original points on. They're a little bold, but at least it gives us a starting point here. And so if we look at the -10 versus the positive, we can see the way that it's flipping. Really, in terms of the strength, it doesn't seem like too much is different in terms of the strength, unless maybe it can be a much larger number. The radius, that also really doesn't seem to do too much other than change the icon. I could be wrong. Let me know if I'm wrong. And then the decay really is the kind of as something extends from beyond there. And so if we increase this back to 1,000, minus doesn't seem to do too much. Maybe I'll even increase this to 100. We'll see if it makes much of a difference. That also doesn't seem to do much. I think we'll see as we use multiple forces, the decay will allow them to interact in different ways. But really, one of the biggest things that we have going for us here is the number of steps as it relates to this. It just allows those, the kind of trail to be longer as this is moving around. So all of that's working at least. We can hide our force. We can hide the merge. And then we have our curves there. Let's incorporate, well, we can see this is also beginning to be three-dimensional. If you want, you could increase your number of, you can increase your density. So the steps, maybe you want to increase to 10. Well, you can see the way that the field or that the array of points gets more dense, and then our lines get a little more dense. We could even hide the points. So now let's do a couple of things. Let's copy this, and we can feed one of our other lines that we created into the container. So we can clear that value. We can set one more curve. And I might just change, well, let me leave it and then we'll change it. I'm going to add, hold down Shift to add another field to here. So now we can see what begins to happen. These are both positive. I'm going to leave, let's see, the radius and the decay. I'm going to keep the strength as an independent value, but then radius and decay can be shared because they don't seem to do much. And here's the difference. If you play with it, you can go from 10. I've started to see that when I use in opposite directions, it works a little nicer in terms of decay. That's minus. So a smaller value, closer to 0, with no decay, allows the forces to impact the curves for a greater distance. And so this is now two directions kind of moving in relation to one another. So even if we changed the top one to negative, we can see the way that they start to join. They're moving in the same direction. And then if we change this one to positive, we'll see the way that they work. So you can even now, as you move between the two, we can see that our second force here is smaller. This one is larger. And so this is minus 10, this is 1. And so as I change this second slider, we can start to see these begin to balance out. And this kind of crease between the two will move over to the center between them. So as we move this up to plus 10, now we see what happens there. So let's just copy this once more. Well, we can also see we can change the height. We can even turn this back on and see where that is. But let's copy this whole group and we'll add our third force. We'll see what happens with that. And we'll clear the values for that container. We'll set one curve. It's pretty clear which curve that is. And we'll add this field to our merge. And as that moves in the same direction, we can see what's starting to happen. If we begin to move it in the other direction, so from positive to negative, the way that that works. We can change its height. We can also change pretty easily with our curves by even changing the endpoints. We can start to have a force almost at a horizontal direction. So that's a pretty simple representation. We can see everything that's happening here. Maybe I'll just group all of these together. As our forces, these get merged, and then we have our lines that are created. So if you don't want to play with the representation, you can stop here. But like I said, I want to bring in two more aspects of this. One, using a color gradation. And so the longer lines are a different color than the shorter lines. And then I also want to animate this, and I can show you how to do that as well. So if you want to continue with visualization and representation issues, we'll go from here. So let's deal with the color coding first. And what I'd like to do is add a relay. And the reason why I want to do this is it'll make it easy for us to disable this as we go. So let's see my points. The other thing I want to do before we get too far is I want to flatten our points that are coming out of there, which will just help us with the color coding of these things as we go further. So the relay will allow us to enable or disable things going to the loop. It can get time consuming and computationally intensive as we add more points. So with that relay, let's look at the color first. So the first thing that we want to do is we want to get the length of our curves. So if we type length, you don't even have to type it correctly, but now we'll get the length of our curves. And if we just want to see what that looks like, we can add a panel. And so we've got all of these, and what we'll do is we'll look at the bounds, and this way we can grab our domain from this. And so we'll do bounds. We'll pull these numbers, and then we'll get a domain from the smallest number to the largest number. We can deconstruct our domain, and we can get the min and the max out of this. We'll use these for the gradation or the gradient color coding. Oh. And so our lower limit is going to be our start. Our upper limit will be our end. And the parameter is going to be the lengths. And once we have that, we will do a custom preview. The material will be the gradient, and the geometry is going to come from our relay. Remember, this is coming from our field lines. We can hide the field lines now. And we could even get a little bit, if we right click on the dot, we can get a different kind of more extreme color between these. I think it's a little too extreme in terms of the differences here, but our shorter lines are blue and the longer lines are red. And so this just gives us a little bit of difference between these. Let's see, maybe I'll set this. Let's see, this is 289. We can go, say, a lighter pink. Set this something similar. And maybe go for a deeper, turn the value down for a deeper color. And so we get a gradation from kind of light to dark. And we can see this within the lines. So that's working. The other thing that you'll see is that as the force, depending on where it is in relationship to some of the points, as it gets close to the point, that one point gets kind of swept up in there. And so we can look at moving this ever so slightly. We can see the way that that changes a little bit. If you don't want a really tight ring in the middle. So we have that. But you can see as you move it away, it'll get closer to another point. So you have to be careful about that. So that gives us a simple color preview with the lines. And then the last part will be using a loop. And the reason why I wanted to do this was to see these animated as they originate in the planar set of points into the three-dimensional space. And so we'll also pick up here from the relay. And so we could even group all of these together as the gradient. And then we can pull from the relay down. So let's do a couple of things. Let's start with the Anemone, and we're going to do the classic loop, start and end. We want to connect this across the top, and there are other tutorials with the loop, and I've done a couple, and so we can revisit those, but it's a couple simple steps. Let's look at, I like to use the panels, maybe 50 for the repeat. You can also use a slider, that's fine. The trigger is going to be a button. And we'll look at what the data coming into this will be from our relay. And so we'll work with this data. And the way that I want to do this is to start with dividing our curves. And so we have these curves. I want to divide them up and then split the list so that I draw the curve kind of incrementally along its length. We can also, let's do a couple of other things with the loop while we're here. I want to hide both of these, and let's right click on the end and click record data. So that's good. Let's now split our list, or sorry, let's divide our curve first. And our curve here is going to come from our relay again. And so we're dividing all of these curves. Our count, let's set our count equal to the amount that our loop is going to repeat. So that'll be 50. And then we'll take these points, and this will come from into our list. And so let's do split list. So our points will be our list. And the really simple thing here is that our counter from our loop is going to be the index. We can add a small, actually we don't have to add, let's copy our panel from here. Simple little panel. And now we can have a readout of at what stage our loop is at, right? As it gets to 50. So when the loop starts, it'll be at 1. When it loops a second time, it'll be at 2. We'll see that in this panel, but this is also then the index that it's going to feed into our split list. And so we only want the first list that's created, and we'll now interpolate that curve. We'll do that from list A. It's not liking that. And we'll look at it in a second. It's probably because the loop isn't running yet. So we'll imagine that that's okay. Let's feed this in to our data. Now we see that the error goes away. And let's add a curve. Curve container coming out of our loop. And let's flatten this down, because what we'll do is we'll feed this now into our geometry above. And let's see if we have enough to run this. Yeah, I want to do one more thing, but let's hide everything, because remember we're getting the output above up here with the output geometry. All of that seems to be okay. Let's click our button and see how this goes. So that's working exactly how I want it to, in that what we see at the beginning is our grid of points. And then as this goes through, I'll point this out in a second too, we can see within our panel what iteration of the loop it's on. If we have it set to 50, once it gets to 50, now it's complete. We can spin this around and take a look. It's no different. It hasn't changed from what we had a second ago, but what we've done is through using the loop and splitting that list, we're taking a portion of this line, because we divided it up into a series of points. We're taking a portion of the line and drawing it. So what we see here is the end. And by running the loop, we get a nice simple animation of the creation of those lines. So it's a bit kind of retroactively taking the full line, subdividing or dividing the line down, and then redrawing an interpolate curve based on that. So that's a nice simple thing. The last thing that I wanted to do was to create kind of not quite arrowheads, but just a kind of thickening of the line to show where it's kind of starting and where it's ending. And so the easiest way to do that is let's grab our endpoints from our curves. And so we'll go from this interpolate curve into our curve. We can see we get the start and the end point here. And let's take from that curve, we'll put another point on the curve. We'll pull this from our curves, but this time I'm going to set it to almost the end, right? If it's at 1, this is going to be the same. It's going to be 100% at the end of the line, which will essentially be the same as this end. If we pull it back just ever so slightly, I can even zoom in here. Here it is all the way at the end. As I pull this back ever so slightly, we can see the second point created. So what I'm going to do is just simply draw a straight line between these 2 points. I'll pipe that, and then we'll have a nice simple little representation of this. So let's do a line and the start and end point. And remember, the end point will be there and the other point will be there. And now we can see between these 2 points, we have a simple line. We can hide our points, we can hide those points, and now we have just the line at the end. Let's do a pipe. And the pipe can be computationally intensive as we do these things, but it's just a simple line. So now we see our radius is too large. We can dial this down. I'm going to go 0 is less than 0.500. 0 less than 0.500. Enter. Turn that up ever so slightly and plug this into the radius. So now we see we get a nice little thickened line at the end of our curves. Just turn that down a little bit, and let's give this a custom preview color as well. The pipe is the geometry, and maybe we'll give this a swatch. And in this case, maybe we'll give it a dark purple line. And again, we can make it a little thinner. We have a lot of control with this, both in terms of its thickness of the pipe and in its length. Right? If we want to make it longer, we can use our point on the curve, which is the end point of that line. If we want to make it small, it can just be that little end. And again, I just wanted just a little kind of thickening of the line at the end so we can watch it as it's animated. So let's take a look at that. Looks like everything is hidden. And let's just hit our reset button and see how that looks for the animation. The tick on the end of the line does get a little bit longer over the course of the length, because remember, it's using a percentage of the line. And so the longer the overall line becomes, the longer that tick mark at the end also gets. So that ran through everything there, like that. And now we can play a little bit with the forces. And as you do that, here's my recommendation, is this is why I added this relay, is that we can disable all of that and turn on the curves, preview the curves. Now we have a really simple, quick representation. Anything that comes after that is just simple visualization. We could manipulate our forces, either using the endpoints and changing maybe the forces that are there. So either positive or negative. You play a little bit with the decay. But again, I think having played with this, I tend to it's kind of nice when it goes negative, but having it closer to 0 Seems to work nicely. And maybe we can even just change that. So it's -10. Let's go. We'll set it to 0. Okay. And so just in that range is kind of nice. Something between, and maybe even seems like not much happens when we go to 100. Maybe just set this to 1. And so there's quite a lot of range from 0 to 1. So play a little bit with those in terms of the strength and the decay. And once you have something that you like, that's good. The other thing that we could do now is turn up our number of steps so we can increase the density. If you want to see what that looks like, we can turn on these points. We can go from 10 to maybe 20. So now we can see how dense that grid is. Turn off that preview. And this is why you don't want everything updating. The loop will run automatically. And so you probably want to save at this point. But once we enable this relay, now we'll get our visualization. So we can hide our lines there, our field lines, and now we can re-enable this. And now we get our animation. More points look better, but we can also see that it's running a lot slower. We're almost halfway through the loop now. I can run it again in a second. I want to zoom in once we see what the final version looks like. Almost done. And it slows down as it gets closer to the end because all those lines are longer. They're getting divided, and then it's getting interpolated. So there's 50 steps. We can always turn this down. That's another place where you can save if you're having some problems with your computer. Not seeing the variation in lines the way that we were. I'm not sure if this has to be rerun in order to see that. But we could also, the tick marks seem a little small now as well. So we could increase them slightly. And so we have a sense that our grid kind of starts within here. So if we want to get a little closer, I'll run the animation once more, and we can get a sense what that looks like. And all we need to do that, and if you want, let's see, we could probably turn this down. That's going to be just tied to the division of your interpolate curve. So 50 is going to be a really smooth animation and really smooth curve, but let's turn this down to 10. Let's see what that does for us. Let's reset it. And so the animation goes a lot faster. The curves may change slightly because there's less division in terms of its interpolation. Maybe we'll try 25. We can reset it. And remember, we can also, the overall length of those curves is tied back to or comes from the field line component. So if we want to just get a very short line, we can, and I wouldn't change any sliders while that's enabled. Let's turn this down to maybe 100. Re-enable this. And now this should be a much shorter line. So we get a little bit of length on them. And so if we want it to be, I think it's worth looking at even a little shorter. We'll set it to somewhere around 40. We can re-enable. And so this might just be if you want to have more of a two-dimensional field. We can see we're almost done. So there's 25. A little more controlled, but we get a sense of the 3 rotational forces that are there. But again, remember, we can also turn that way up. The default is 1,000. I bet we could even go to 2,000. And this is even a moment where I'd rather not have a slider. And I can just set those numbers as I want them. Let's enable the relay. And so we get a much longer set of curves, more density because of the length of the line. And if we want more points and more lines, we can increase the density with our original all the way at the left-hand portion of the Grasshopper definition to have more lines. So that's the longer lines. So see what works for you, see what makes sense, and play a bit with the representation of these things. And let me know how you do. Let me know if there's any questions. I think it's a really kind of, I'd say, fun way to work with this. I love the density of the lines. I love seeing the kind of forces and the overall form that's created with this. And so I'm sure that we can make all sorts of different things using this as a technique. So let me know what you come up with. Let me know if you have any questions. I hope this helps. I hope this gives you a little bit of confidence in terms of dealing with the fields. It's also pretty nice in that the fields are native components to just the basic Grasshopper. No plugins necessary. It's only if you want to start to animate something do you need the loop or anything else with that. So have some fun. Let me know how you do. Thanks.